all about InfoBridge. Before I get to InfoBridge, let me show you how you can get to it. There are a couple of ways. Number one is infohighway.fhwa.dot.gov. This is the Federal Highway web portal, and it houses 4 sub-web portals: InfoPave, InfoBridge, InfoMaterials, and InfoTechnology. InfoPave is all about pavements. So it houses data and tools on some 2,500 test sections. You'll find pavement performance data and additional tools and references for on pavements. InfoBridge we're going to talk about extensively later today, so I won't say much about it, but it's all about bridges. InfoMaterials is where we house all kinds of research data that Federal Highway has been collecting on materials. We also host data collected by others. So the first 3 portals are all about data, and it's mostly the data collected by us. InfoBridge's data, NBI data, NBE data we have collected. And now we are trying to get state DOTs and universities to also share their data with us, which we will be glad to host and post it on InfoBridge, because we simply cannot collect all the data in the world. It's expensive, it's time consuming, and there is so much data already being collected. So that's another activity that is getting underway at Federal Highway Administration. The last one is InfoTechnology, is really a knowledge portal. There you will find information on all sorts of NDE technologies, the most appropriate ones for any issue you might be dealing with, researching about, for bridges, pavements, and tunnels. So this is one way to get to InfoBridge using this Info Highway portal. You simply click on this link and you will get to this site. That is the InfoBridge website. Similar address, infobridge.fhwa.dot.gov. If you simply Google InfoBridge FHWA, the first hit will be InfoBridge. So this, as Nancy mentioned, is a workshop. It's not a boring lecture I'm going to be giving you right from here and you simply listen. No, so this is a workshop, and let's make it interactive. So while I go along, if you have any questions, if you're trying things out on your computers as well, and you are stuck or need some directions, please interrupt and ask me for help. So initially, I'm just going to give you some background about InfoBridge, a short, maybe 10 minutes or so, and then I'll get into the workshop part. So as I said before, this is Federal Highways Bridge web portal. This was developed and first released in 2019 at the Transportation Research Board's annual meeting in Washington, D.C. And since then, we have been updating and maintaining it. And that's one of my main duties at Turner Fairbank Highway Research Center, which is the research arm of the Department of Transportation in McLean, just outside of Washington, D.C. We did this for various reasons. Number one is, by law, we are required to do this, make all the data that we collect easily available, machine-readable format. So that's one reason. Second is, we want to analyze this data and come up with tools and products that are useful for bridge owners. And thirdly, we hope this vast amount of data that InfoBridge houses can be used by other researchers around the country, and they can come up with tools and products that will help the entire bridge industry. So these are the 3 main objectives of why we developed this in the first place. So heart of InfoBridge is data. As I said before, it houses national bridge inventory data on some 621,000 bridges in the country, all bridges 20 feet or longer on public roads. It also has the NBE, the National Bridge Element data. Almost half of the bridges in the country have NBE data, and the number is growing. Thirdly, we also provide for every bridge historical climatic data from NASA's MERA-2 website. And then we have data that we have collected, the long-term bridge performance program at Federal Highway, and we are conducting some experiments. That experimental data is also available in InfoBridge. So you can see there is a lot of data. Maybe most of this data is available in different forms on the web. However, what InfoBridge is doing is it makes it very easy to access and all in one place. So this makes the InfoBridge very, very useful, and I think you'll like it, and in fact, I believe you can actually use it in your everyday work, and we'll see why. We'll show you some of the tools and products that are in the InfoBridge. So number one use of InfoBridge is, like the name suggests, information about bridges. So you pick a bridge, you pick a group of bridges, and then you can look at all of their information, basic information such as length, width, where it is, who maintains it, what it is made of, and so on and so forth. And also the condition ratings of its three components: deck, superstructure, substructure, and the condition of the bridge as well in terms of good, fair, and poor. So this information is critical in terms of developing your TAMs, for example. You need to have the inventory at your fingertips. You should know about how the bridges have been performing over the years, and you would also like to know what they would be doing, how they would be performing in future. So we have tools to do that as well. There are tools to even value your assets, so-called asset valuation tool. So it will tell you the worth of your bridges if you are going to reconstruct, rebuild all of them, or in terms of their current value, which really depends on its load carrying capacity and the condition of the bridge. And this information together can help you figure out what to do with a bridge, whether to rehab it if its value is really high compared to its replacement value, or if it's really in bad condition, perhaps you want to just replace it. So I said a lot that I'm going to cover later on in this workshop, but I think this will set the stage in terms of you understanding and appreciating what will be presented in the hands-on workshop. This website is free. It's free for all. No login information is required, and we do not track anything that you do in terms of which pages you're looking at, what data you're downloading, or any reports you may be creating. So that's important to mention. So before I get going, showing you different components of it, I would just like to know by show of hands, how many of you have heard of or used InfoBridge before? All right, I see a lot of friends here and a lot of prospects, so, which is always a good news. We have about 1,200 users per month, and our objective is really to grow that number to perhaps 6,000 or 8,000. It's a tall order, but the reason is because I believe there are at least about 6,000 to 8,000 bridge engineers. And what we are doing is being done with your money, public money. So you want to make sure it is being put to good use. So please go ahead, use it, talk to your colleagues about it, and let them know how wonderful this product is. So with that, let me get going. And so InfoBridge basically has three sections: the data, analytics, and tools. And there is a library section which basically gives you information about InfoBridge, all the updates we have been making throughout, since 2019, the long-term bridge performance documentation, which includes, by the way, the data collection protocols. As I mentioned earlier, we would like to host data collected by others as long as it is collected using the protocols that we have posted here. The reason, as you can appreciate, is we want to make sure the data is consistent throughout whoever is collecting it. It makes it easier to use it for any research purposes you have. Else, data you collect, I collect, maybe have different conditions, and you may not be able to use it uniformly in your research program. So the data collection protocols are important. So if you would like to share your data that you are collecting, we would be more than happy to do that. Please contact me or any one of us at Federal Highway, and we'll do that. So let's go to the data tab, and this is where you will find information on 621,000 bridges in the country, 20 feet or longer on public roads. InfoBridge has a lot of querying tools to come up with a short list of bridges that you might be interested in, and then look at all of them collectively or one bridge at a time. So the basic filters are under Find Bridges. These are basically the most commonly used NBI filters, such as like state or structure number, feature intersection, owner agency, and so on. Additional filters are under Advanced Find, and they include the rest of the NBI filters, NBE filters, even MPO, Metropolitan Planning Organization, political districts, and cities. You can even search by these entities. Special projects, these are the projects that Federal Highway has conducted in the past, timber bridges, ultra high performance concrete, or unpainted weathering steel bridges. So you can find data on that as well. There is a map find feature. In the map find, you can simply draw a boundary using one of these tools and look at all of those bridges included within that boundary, for example, or simply look for a city and shortlist bridges in that particular city. There's a chart find. I'll just quickly show you what that is. Chart find really gives you a snapshot of everything that's available in InfoBridge in different categories, and you can select any group of these bridges and then look at those bridges under the selected bridges table. So let's get back to selected bridges table. So once you have all sorts of filters assigned, let's say we go to South Dakota here. South Dakota number 46. Now you can see there are 5,889 bridges. That includes culverts as well. Let's say we don't want to include culverts. You simply go to 43B, and out here you say exclude culverts, and culvert is number 19 in NBI. So you select that, and now we are down to 4,296 bridges in South Dakota. So let's focus on those bridges. So to make that list or those filters active, you simply click on that and turn that red button green. So now you're looking at 4,296 bridges in South Dakota, no culverts. If you wanted to look at, let's say, national bridge elements as well, as I said before, out of 4,300, you will see that only 724 bridges have national bridge elements data. So let's just deal with the 4,300 bridges in South Dakota. So what can you do with all of these bridges that you're seeing here on the screen? Well, you can simply go to scroll down, and down here you will see the NBI data for each one of these bridges. So for example, here you can select any year, and the NBI data is available in terms of tables here, or also in terms of graphs. And these graphs can be saved as an image, or you can even download them as XY pairs and create your own plots in Excel, for example. If this is one of the NBE, this is not. So there is no NBE data available for this bridge. Had there been data available, it will be shown here for the NBE data. And as I said before, the climatic data is also available. Certain attributes are being shown here. Oh, sorry, I don't know this. I should have turned this off. It's always a prank call. Never the call that I'm interested in. So the reason for providing this climatic data is, again, for researchers to use it to see if there is any relationship or any of this is affecting bridges' performance. We talk about bridges being affected by loads, obviously, and climate as well. Not only the climate, but also the salt usage. So although we don't have that salt use information available right now, because that data, although is available with certain DOTs, it is not available nationally. So in fact, we are embarking on that activity very soon. We'll be contacting DOTs to collect that information, and if it is sufficient and covers most of the country, we'll make that available in InfoBridge as well. The reason again is for researchers to use this to come up with understanding of bridge performance, what has been happening to our bridges, why, and what we can do to prolong their lives. So there is a condition forecast tab. Under this, for each bridge, you can see the historical performance of, say, decks, the deck, the superstructure, substructure of this particular bridge, and from all the way up to 2023, and from here on, these are forecasts. So, and you can turn off, say, lower bound, upper bound, lower bound, and let's say medium, and we're looking at mean. So it's predicting that this is what is going to happen to the deck in future. There are three models here. The base model, machine learning models, and survival models, or proportional hazards deterioration models. The base models is the simplest of them all. It's basically a regression analysis of selected bridge sets, and it basically calculates the standard deviation, mean, median, and so on, and uses that to predict what could be happening to deck, superstructure, substructure in future. Machine learning model basically crawls over all of this data, NBI data, and looks for relationships and patterns and uses that to come up with forecasts. And the proportional hazards deterioration model looks at the various condition ratings and their durations, which factors affect those, and then uses that information to predict the future conditions and their durations. The machine learning and survival model, they're like big data products, stochastic, in other words, probabilistic models. So there is certain probability associated with it, and the graphs will show you the similar to the upper bound, lower bound. And you can use that with some other tools that you may be having, some of the historical information you might be having. And so since this is probabilistic, and interestingly, these three models will probably give you three different predictions. So you will have to use your own judgment to understand and put all these in proper perspective along with your own local data and experience, and then use them to really come up with forecasting of your bridges. So that's a little bit about the component forecast. If you wanted to look at the performance, by the way, you can also plot all of these bridges on a map. So they are right here in South Dakota. We can also show them in terms of all these various attributes: bridge condition, the deck condition, the age, bridge age, and so on. Let's say we do it in terms of bridge condition, and now you can expand on it, and you can see here all these dots. If these dots are too small to see, you can always use a thicker symbol, a larger circle, and you can see there are all kinds of mix here. Good, fair, and poor condition bridges. And if you wanted to see in numbers what they are, you can go to Performance History tab, and here you will see in numbers, in terms of number of bridges, the good, fair, and poor condition bridges by systems, all bridges, interstate highway, and non-NHS bridges. And this is in terms of count, and this will be in terms of deck area of bridges. Down below, you'll also find some historical record of these conditions, all the way from 1993 onwards. And you can see that in general, the number of something happened and number of good bridges suddenly dropped big time in like 1990. I know what that is. Maybe people from South Dakota may have some idea. But then they are being held to a pretty constant number. The number of fair bridges are being held to a constant number as well, and number of poor bridges are increasing slowly. We also had tools, and I'll show them a little bit later, to predict what may be happening beyond 2023 to these numbers. So that's a little bit about performance history. By the way, in selected bridges table, there are a lot of things that you can do. For example, you can search for the oldest bridge in South Dakota by simply clicking on this on the top. There are bridges built in 1900, and you click it again and it will sort the order from latest to the oldest. You can look at the owner agency. Again, you use these filters. You can use these filters here as well. You can, the filters that we have applied, and you may be applying a lot of different filters to really get to a short list of bridges that you are interested in certain county, in certain city. Bridges may be made of concrete only. For example, if you wanted to know how many concrete bridges you have here, you simply go in here and say include concrete and concrete continuous. These are the NBI fields, and out comes the number of concrete bridges. So out of 4,300, there are 1,566 concrete bridges. The rest are probably steel and maybe a few timber bridges. You can do the same thing here to find steel bridges, for example. You just go in here, and now this time you include steel. Steel and steel continuous, and there comes the number 1275 steel bridges. So concrete is slightly higher than steel, and the rest are probably timber bridges. And we are only again talking about bridges only, not the culverts, but you can look at culverts only also. Yesterday there was a presentation on by Michigan, one of the counties in Michigan, and they were looking at their bridges and culverts in terms of their conditions, and they even had some forecasting tools. InfoBridge can also be used to do just that. It will show you the bridges on a map in terms of their conditions and even forecasts. So I don't know if the county chief is here in the audience, maybe not. Maybe I'll send him an email later, because I'm sure I'll find him in the attendee list. So that's how you can do the different sorting for different materials. So back to our bridges table. You may want to look at what kind of bridges are scour critical. So a lot of different tools are available to really help you figure out conditions of your bridges, the bridges you may be interested in. And you may be wanting to compare the state of bridges in your state with respect to your neighboring states, and see if there are differences and why they are, and maybe you can collaborate to find better solutions to maintain your own bridges. So InfoBridge, because it's a national database, can really be used in many different ways. So I talked about these queries. You click on this and it will tell you exactly what filters we have applied for this particular group of bridges. Sometimes this list gets very long, and you may be dealing with that group of bridges on a regular basis, and you don't want to be applying those filters every day. So there is a feature here. You can save these filters as a group, and you can reapply it every day, and you will be back to this same group of bridges that you have been studying, you have been looking at. And that one is right here under Find Bridges. You can save the filter criteria, and once it is saved, you can open that filter criteria any other day, and the same filters will be applied. This table has a lot of information. All sorts of NBI data is available here. Under table options, you can export this data. And you can export this data in terms of the latest year data, or all years. For all of your bridges, all of the NBI data for all years can be exported. And or you may be only looking at, say, last 10 years or certain number of years. You can use that feature, year range, and you can only get data on those bridges for those many years. And this data comes in as a CSV, but there is a link here that explains to you how to bring that into Excel. And once it is in Excel, you can do all sorts of analysis of your own, plot it, make all sorts of presentation graphs, and use it any which way you want. Maybe you want to use your own tools, come up with your deterioration models and whatnot. So we talked about the map feature, performance history feature. Under performance history, we looked at this, but we also have this another tab. See, a lot of times you want to know what has been happening to your bridges. Is there a certain trend in terms of how they have been performing over the years? Let's say you wanted to know bridges that were in fair condition in 2019 and now they have become poor. Which bridges are those? And if you click on it, out comes a table that tells you exactly the structure numbers that these bridges, since 2019, this has been happening to them. They were in fair condition all along, and in 2023 they have become poor. And this gives you all of this list. This list can be exported into Excel again. In this case, there are 196 bridges that have done that. So you can get all of those in table. You don't have to keep looking at it here and bring them into Excel and look at it later. What this does is give you an idea of what sort of deterioration has been happening in the past. The reason for this is we do have prediction models that forecast the conditions in future. And a lot of times people want to balance that with what their experience has been and use the forecasting with a grain of salt. And this came to us from one of our bridge engineers from North Carolina. And he said he used to do that when he was at North Carolina's DOT regularly. This is how they figured out or forecasted what could be happening to their bridges 5 years from now by looking at the past history. And he said that is very useful. And he said he now uses that as well as our forecasting tools and use them collectively to make an informed decision. Because this, mind you, the InfoBridge is based on all 621,000 bridges. So it is impossible to have same sort of conditions, maintenance practices and whatnot throughout the country uniformly. It is going to change from region to region, state to state, county to county, city to city. So a lot of times you want to use these tools, but then moderate them in terms of your own experience and the data you may be having. So that's a little bit about performance history, transition history. If we get to now the performance forecast tab, here, first of all, it shows you the same the plot that we saw earlier, good, fair, and poor bridges. But now we can come up with forecasts of what could be happening to these numbers, good, fair, and poor, in future. So here we only had two models, the survival model or proportional hazards model and machine learning model. So let's use the first one here, and out comes the forecast. Might take a couple of seconds because it's going through a lot of number crunching. So you can see if we have the minimal maintenance like what we picked here, limited preservation, then this is what is going to happen. The number of poor bridges is going to increase very rapidly. But you can see what if we really had a maximum preservation activities. If we did that, obviously the graphs are going to be very different. This was with limited preservation, this number of poor bridges with maximum preservation. So Mind you, the preservation that is being assumed here, we really don't have any data in NBI about preservation activities or budgets or spending. So we use some surrogates to come up with these preservation levels. And more of that is available in InfoBridge library section. All of these models are described very clearly. And these two models we're looking at, they're pretty complex models. So there are longhand papers if you really want to get into the nitty-gritty of these methodologies. However, we also have simple, easy to understand one-page, two-page descriptions of these methods. So I encourage you to go there and learn more about these methods in under library section. So this is a one forecasting tool that we have. Now, this only gives you the number of bridges that may be transitioning to, let's say, poor condition. What if you wanted to know which bridges, specifically which structure numbers we should be targeting? We think may be transitioning from certain condition, let's say good in 2023 right now, to, let's say, poor in maybe 10 years later, 2033. With a 50% chance of this happening. Again, because I said all these models are probabilistic, so it depends on this number, the number of bridges that comes up with. So obviously, if you increase the probability of occurrence, the list will get shorter, because now you want prediction with a lot more confidence, then the number is going to be smaller. So here you can see the table. There are 35 bridges that this tool, this particular model, which is this model here, limited preservation model, is forecasting that these bridges would be transitioning from good right now to poor in 2033. So perhaps you may want to look at these in detail and see whether it makes any sense what this is talking about, and then accordingly program these bridges for rehab or replacement in future. So this is another very useful tool that you can use. Back to the analytics. So this tool is really for preparing presentations, and it has the charts feature. Under charts feature, you can have either a single variable chart or two variable chart. On the single variable chart, for example, you can drag and drop any of these items on the right, and out comes a plot that shows you, in this case, the number of bridges in good condition, fair condition, and poor condition. You can save this as an image and use it for presentation to your superiors, or at a conference, or for in your group, or for whatever purpose you may want to do that. Under two variable chart, similar thing, you may want to do the bridge age versus bridge condition. And out comes such a graph, and this maybe we want to swap these bridge age here and perhaps bridge condition here. Okay, so this is easier to understand. So now you can see it gives you different age ranges, and during that age range, what is the distribution of fair, poor, good, fair, and poor condition bridges. So this is another interesting and useful tool to look at your bridges, to understand the performance of your bridges. There is a bridge condition by state option here, and here you can see this information about good, fair, poor bridges nationally in every single state, and you can pull this down and look at either good, poor, or fair condition bridges by different systems, and here is a table of all of that information as well. So that was the bridge condition by state, and so one more tool I would like to talk about. Two tools maybe, these are interesting. This is the asset valuation tool. And we talked about the condition and which bridges might be transitioning to fair or poor, or what we may or may not want to do with those. So the asset valuation tool is also very useful tool. What this does is it gives you the value of your bridges as they are today in terms of their replacement cost. So you can put in any number you like here. You can use either national average or you can use the number for South Dakota, and that is given here. It's not too different from national average, it's almost identical. By the way, these numbers are not our numbers. These are the numbers that we receive from state DOTs, and these are the numbers that are being presented here. But obviously, if you are doing this for a certain county, certain area of the state, this state average may not be applicable, and you may know better numbers. You can type those in there to get a better estimate. So here it is telling you for all of those 4,300 bridges in South Dakota, their total replacement value is almost like 4.2 trillion, pretty large number. It also gives you a table here for each bridge in South Dakota. It gives you the replacement value, which is simply the deck area times this unit cost of replacement, and the existing value. Now this is really the replacement value that is discounted based on the bridge's condition and the load carrying capacity. As the condition deteriorates and the load carrying capacity decreases, so does the existing value. And that's the ratio. You can see the ratio is pretty high for 90%, so the existing value of the bridges is not so bad. But you can always toggle this, and now you can see the list the other way. These are some of the bridges that have a very, very low existing value, meaning they're probably in a pretty bad shape, and these might be the candidates for replacement rather than rehab. So this is another very useful tool to use in your planning. By the way, the states a lot of times have access to a lot of different tools, like FHWA products, for example. But some of the smaller cities and counties may not. And for them, InfoBridge is really invaluable. So please let your counties know that this tool is also available for them. So this is the asset valuation tool that you can use in your work. I think I'm coming pretty close to the end of the presentation, but there's just one more tool I would like to show, and then we'll conclude this presentation. The historical spec changes. What this does is we have been compiling information, the changes to bridge design specifications for all these various topics. They are being presented here in a chronological order. They are searchable. And again, the idea is so researchers can use this information to understand the performance of bridges designed in different time periods during which certain design conditions were applicable, and whether that had any impact on their conditions going forward. So that's one of the reasons we are doing it. You can also use it if you're looking at an older bridge and trying to figure out what could be going wrong, if there are issues with it, and you wanted to know how it may have been designed with what design criteria. You can use this to search that as well. For example, if you go to reinforcing steel, and in the search field you simply type stainless and search for it, you'll get several hits. It will tell you different things that happen to stainless steel as a rebar. And one thing I'll show you here, which is interesting, I didn't know that either, but the first use of stainless steel rebar in bridge deck was in Michigan in 1983. So it's just one example. You can search for all kinds of things that you might be interested in, and so please use this tool as well in your work if needed. And with that, I think I'm pretty much coming to an end. If there are any questions, I would like to address those. By the way, we do these presentations at various meetings, conferences, and if you find this useful and would like to arrange a presentation for your staff, your colleagues, please let me know. I'll be more than happy to do it. with that, we can open it up for any questions or comments.
I had a question. You know, we're all in the midst of beginning our conversion to SNBI. Are you guys going to be following suit?
Yes, yes.
Okay.
So the deadline is like 2026, when, at least from Federal Highway website standpoint, we'll be converting fully to SNBI. So yes, the work has already begun in InfoBridge. We're trying to figure out what we want to do. Of course, the SNBI will be implemented, but we also have this need for maintaining what we already have, all this database in the past. I don't think SNBI is going to be, the states won't be required to update all the historical data. So we had to figure out how we want to deal with it. But yes, that work has already begun, and we are in the brainstorming period right now. Yes, there is a question in the back.
Is there an API available?
This question comes up quite routinely. No, we don't have an API right now, but maybe write to me, tell me what exactly you are interested in doing, and we'll see what we can do.
So I would want to integrate, a lot of the data that you have behind the scenes into a product solution.
Okay, so all the data that we have here is downloadable in InfoBridge. So that's one way you can do it. Just download everything, and then you can use it any which way you want. But if you really want to use one of our tools through an API, then that's a different need altogether. But yes, see me.
Downloadable. Sorry, I'm very loud. API versus downloadable is that then you have to just create an ETL process to consistently download it. So.
Yeah. It's not the most efficient way of doing it. API would be ideal, but we can talk about it.
Yeah.
If there is a large demand for it, we'll consider it. But right now, we haven't heard too many requests for an API.
It's a great tool and great data. I appreciate you.
Thank you very much.
Follow up to that, I thought you could only download the latest year and not like a historical subset of the data. Did you change that?
You can download historical data as
Okay.
well, for all years, for a certain number of years, or the latest year.
Okay, all right, thanks.
And if you have any difficulty downloading, because if you really went to all 621,000 bridges in all years, it's impossible. There's just too much data. And if you really want to do it that way, just contact me and I'll get you all the data that you want, Philip. Thank you.